Hello everyone. When it comes to mastering Python programming, there are five important topics. We have already covered four of those, which are functions, conditionals, loops, and lists. In today's lecture, we'll be covering the fifth topic of dictionaries. Please make sure to get a really good grasp of these topics. It is very important that you understand the associated details with these five topics before we proceed with advanced topics for this course. If you haven't covered the associated readings yet, please make sure to go back and complete those. Please make sure to go through every problem as part of worksheets and interactive exercises that we release along with lecture materials. If you have any clarification questions, please get those answered via office hours or via live stream sessions. Dictionaries will be the second example of data structure that we cover in this course. Dictionaries are mapping-based data structures. Mapping-based data structures enable us to associate a specific label with a data value. Inside dictionaries, we'll be storing key value pairs. In today's lecture, we'll be motivating the need for dictionaries. Then we'll learn the syntax associated with dictionaries, including creation, lookup, updates, and deletion. Finally, we'll go through a demo problem for which we already have a solution. We are going to take the existing version of the solution and improvise that by introducing dictionaries. The reading for this particular material is chapter 11 of Downey book. Let me get started by defining the term data structure. As per Wikipedia, data structure is nothing but a collection of data values in such a way that there is some sort of relationship among the values. We'll have functions or operations that can be applied to the data stored within the data structure. We have already covered one example of a data structure, which is list. Recall that lists enable us to store various data types. What sort of relationship do we have among the values? The values have a specific ordering. Each item within the list is associated with a specific index position. Recall that index positions begin at 0 and get incremented by 1 for every item within the list. We have covered various operations that can be applied to lists, including indexing, slicing, length, for loop, various methods like sort, pop, append, remove, and so on. As you keep learning new data structures, it will be very helpful for you to come up with this tabular structure, which enables you to keep track of the associated details. Let me compare and contrast set data structure with list data structure. You'll be learning about the set data structure as part of Lab P6. Just like lists, sets can also store various data types. The main difference between set and list is that set can only store unique values. Within a given set variable, you can only have one item which has integer value of 1. As opposed to that, within a list variable, you can have multiple items which have the integer value of 1. Let's talk about relationships. We already know that items within a list have a certain kind of order. As opposed to that, set data structure does not have any kind of ordering among the items. Because of this lack of ordering, certain kinds of operations like indexing, slicing are not possible with set data structure. With the set, you'll be able to use the in operator, which enables you to look up whether a specific value is part of that particular set. You can use the double equal to comparison operator to compare whether two different sets have the same set of values. Let's go back to the motivation about loops. Recall that I motivated loops by mentioning that copy pasting is such a waste of your time and painful to manage the program. So we learned the concept of loops, which enabled us to execute a given code snippet for a specific number of times. The motivation for data structures is going to be similar. We want to be able to deal with more and more data with fewer and fewer variables. Often, programs are written in such a way that the dataset that is analyzed within the program evolves. When you get started with the program, you'll have one version of the data set. By the time your program is used to actually do the analysis, the data set could have evolved, meaning that you could have had newer entries within the data set. Let's learn about mapping-based data structures. Data structures in general can store many values. You will associate a specific label with each of those values, which will enable you to look up that particular value. The first example for mapping-based data structure is going to be the list data structure. Here I have an example list called nums, which is storing 4 items of 300, 200, 400, and 100. Let's say that I want to associate labels with these values. Those are going to be index positions. Each value has a unique index position. How can you use the label values here to look up the items? You'll have to use the concept of indexing. Recall that if you want to extract the item 400, you'll have to index by saying nums of 2. Lists are kind of inflexible. That's because you can only have specific labels when it comes to lists. The labels always have to be the index positions of fixed integer values starting at position 0. What if we want to use strings as labels? What if we don't want to use consecutive integers and we want to have labels like 0, 10, 20? Dictionaries are going to enable us to do both of these things. Dictionaries offer way more flexibility than the list data structure. Let's first learn why the data structure is called as a dictionary. Some of you might have heard about this book called Dictionary. It's a book where you can learn meanings of new words. Let's say that you want to learn the meaning of the word breakfast. You can look it up in the English dictionary. In the book dictionary, the values are ordered based on the alphabetical order of the terms for which you want to learn the meanings. In Python dictionary, we have something which is called as insertion based ordering for Python version greater than 3.6. I'll talk more about insertion based ordering when we introduce example for dictionaries. Dictionaries in Python are often referred to dict as short. Let's learn what sort of details are associated with the dictionary data structure. You can have any data type as value within the dictionary. Just like you can store lists within lists, you can also store lists within dictionaries. Keys can nearly be anything. What are keys? The labels are called as keys when it comes to dictionary data structure. In list data structure, the labels are simply the index positions. Keys can nearly be anything, but they must be immutable. We'll cover the concept of immutability of dictionary keys in detail as part of next week lectures. Let's consider a list example here, which is nums underscore lists, which is storing 3 items of 900, 700, and 800. Recall that if you want to extract the item 700, you can perform indexing by saying nums underscore lists of 1. A dictionary would let us use different labels instead of the fixed index positions of 0, 1, and 2 here. Let me define a counterpart example for a dictionary here. I'm going to use the variable name here as nums underscore dict. Nums underscore dict is storing the same values as nums underscore list. Let's talk about the differences between these two definitions here. When you define a list, you'll be using square brackets within which you'll have comma separated items. When you define a dictionary, you'll be using curly braces within which you'll have comma separated key value pairs. Each of those entries are called as key value pairs because you have the label, which is the key, and the data, which is the value. Be very careful here because we have already seen another data structure which uses curly braces, that is the set data structure. So how can you differentiate between the set data structure and the dictionary data structure? You'll have to look inside the values. If you have a colon, then you have a dictionary. If you don't have a colon, then you have a set. Just like we have labels as index positions within the list data structure, we are going to have labels as keys within the dictionary data structure. Observe that we associated the labels as strings with the values here. String first is going to be the key for the item 900. String third is going to be the key for the value 700. And string second is going to be the key for value 800. We can choose any sort of labels as keys as long as they're immutable. Let's go through how we can perform lookup operation using dictionaries. The dictionary lookup is very similar to the indexing in lists. You'll just have to say the dictionary variable name and within square brackets the key whose value you want to look up. You can always go from a key to a value, but the other way is not possible. With the value, you cannot find the associated key. So the mapping here is one way. It goes from the key to the value. Let's go through example lookups here. When I say nums underscore dict of second, that's going to retrieve the value 800. If I say nums underscore dict of first, that will give me 900. Similarly, nums underscore dict of third is going to extract the value of 700. Let's learn about insertion based ordering. When it comes to lists, it's always insertion based ordering. What exactly do I mean by that? The ordering of the items comes from the order in which you add those to the list. For example, in nums underscore list definition, I specifically mentioned 900 item first, 700 item second, and 800 item third. So that's going to be the ordering for these three items here. Let's say that I'm using an append method call to add one more item to this particular list. That particular item is going to be given the position of 3. Your index positions or labels are always going to be based on insertion ordering. Let me talk about dictionary data structures. Up until Python version 3.6, there was no guarantee with respect to the ordering of the key value pairs within a dictionary. What do we mean by no guarantee? The key value pairs could have any random ordering. When you define a dictionary, it does not guarantee that those key value pairs go into the dictionary in the same order that you specify them as part of your dictionary definition. That changed after Python version 3.6. From Python version 3.7, dictionaries also have insertion based ordering. What do we mean by insertion based ordering for dictionaries? You mentioned the first key value pair here as string first and value 900. So that's going to get entered first. The second key value pair is string third and value 700. So that's going to go in next. And finally, you have the second key with the value 800, which is going to be the final entry within your dictionary here. We have covered various usages of parenthetical characters. Let's learn the differences between all of those here. Recall that the technical term for multiple meanings for a specific character is called as overloading. Let's do a quick recap on parentheses. We have used parentheses in two different cases. One, when we want to specify ordering of operations within an expression, and the second is associated with function definition or function invocation. Let's learn various usages that we have covered so far with the square brackets. We have covered multiple usages for square brackets. First one was for creating a list. Look within the square brackets. If you have a comma, then you're defining a list. The next example that we covered for usage of square bracket is indexing. If you neither have a comma nor have a colon within the square brackets, you're either indexing or doing a dictionary lookup. Both of those are very similar. So we have covered three of these four options here. Let's talk about the fourth one, which is slicing. When you do slicing, you'll be using a colon to separate the start index position from the end index position. So look within the square brackets to determine which one of these operations you're performing. Let's talk about curly braces. We've used curly braces for set creation and dictionary creation. How can you differentiate between the both? Look into the items which are separated by a comma. If you have a colon, then you're defining a dictionary. If you don't have a colon, then you're defining a set. Here is a tricky question though. If you define a variable and initialize it with empty curly braces, are you creating a set or are you creating a dictionary? Turns out that you're creating a dictionary because that's what the creators of the data structure decided to define it as. So when you say D equal to open curly braces, close curly braces, you're defining a dictionary. Here is another way for you to define an empty dictionary. You can say D equal to dict open parenthesis close parenthesis. In a similar way, if you want to create an empty set, you'll have to say S equal to set open parenthesis close parenthesis. You can create an empty list either using L equal to open square bracket close square bracket or by saying L equal to list open parenthesis close parenthesis. Let's learn various mutation operations with respect to dictionaries. The first operation that we are going to learn is the update operation. I have a list example on the top and a dictionary example on the bottom. We are defining a variable LST, which is storing a list of 3 string values. Those values are 0, 10, and not set. Recall that you can simply use indexing to update an existing index position value within a list. Let's say that we want to change item number 3 here to string 20. We can simply do that by saying lst of 2. Let's go through similar dictionary example here. I have a dictionary where I have similar values. The keys here are going to be integers 0, 10, and 20. Of course, you can have integers as keys within dictionaries. If we want to update the value associated with the key 20, we can simply do that by saying d of 20 equal to the new value, which is going to be the string 20 here. Similar to how you use indexing to make updates within a list, you're going to use lookup to make updates within the dictionary. Let's go through deletion operation with a list and a dictionary. Recall that you can use the pop method to delete a specific value associated with a certain index position. Pop method call takes the index position as argument and it's going to remove that particular value from the list and it will also return that value. So when you say lst.pop of -1, that's going to remove the item which is at the last index position and it's going to return string 20. Similarly, you have a pop method for a dictionary as well. You can pop the value associated with a specific key by simply saying d.pop of 20. That's going to remove the key value pair from the dictionary and it's going to return the associated value as the return value. Let's go through insertion operation. Recall that you cannot use indexing to insert a new item within your list. Python will throw index error, then it will be unhappy. You'll have to use the append method. For example, let's say that we want to append the value string 20 within the list lst. We'll have to say lst.append of 20. Recall that list methods have an impact on the values stored within the original variable. So the original variable lst is now going to have 3 items which are 0, 10, and 20 as strings. Let's look at a similar example using dictionaries. Dictionaries are kind of nice when it comes to inserting new key value pairs. You can use the same syntax as updating an existing key value pair. you can simply say dictionary variable of new key equal to new value. So the syntax of d of 20 equal to string 20 will work when it comes to dictionaries, and that's going to insert the new key value pair of 20 colon the string 20 within the dictionary variable d here. I'll wrap up this video here. In the next video, we'll start talking about the demo problem.